Hi, this is Renaud from Agilian, and I'm going to talk about risk reduction when developing a new electromechanical product. So let's get into it. In the simplest form, the way to explain it is as follows. As you move along through your product development and going into manufacturing, you address the technical risk. Okay. At the very beginning, you have to work on picking the right design architecture, clarifying what the user experience is going to be, what the industrial design should look like, and so on. You have to pick the main components. You have to do a bit of risk analysis and address the main technical difficulties, but also maybe compliance and regulatory issues and so on, right? So you need to have a risk-based approach here. And very often companies have to do proof of concept prototypes and test them and talk to specialized suppliers and see what is possible and so on and so forth. Then the direction is clearer for going into proper prototypes. So prototype 1, 2, 3, 4, 5. There could be a lot of prototypes. The idea is that as the engineering design gets done, the issues, of course, get surfaced because that's the nature of engineering design and any development work. And people find ways to address these issues, go around these issues, find other ways to go at it. But a lot of the groundwork has been done here, typically, if this was done well. Okay. But as you go, you chip away at the risk. And at one point, you validate the product design through reliability and environmental testing. Okay, and then you go into pre-production pilot runs and then into mass production, right? So you actually validate the process design, right? For manufacturing, for testing, you validate all this. As you do it, you reduce the technical risk. Again, this is technical risk. We are not talking about market risk, financial risk, any other risks that that might impact a project of bringing a new electromechanical product into the market. So what we call NPI is new product introduction, is a very common expression in electronics, but it's getting more popular. And basically, it is the process of bringing a new product into mass production with low risk, or let's say a controlled amount of risk, because it depends on the priorities of the project team, obviously. And we like to cut it in 6 phases. Now, we have another video where we go into this in details. You can find it on our website. So, but basically, number one is to document the product requirements, so we know actually what it should do and what is the typical use case and how it's going to be used and so on and so forth. Feasibility study, as I mentioned, a lot of things usually, if it's really an innovative product that is nothing like a current product already on the market, there's usually a lot of things to look at. Then prototyping iterations all the way to setting and confirming the product design and freezing it. Then usually, if there's, for example, a custom enclosure in plastic or something like this, some tooling has to be fabricated. That takes a little bit of time. There's usually some other work in the background. But then again, this leads to the ability to do reliability testing, compliance testing, and so on. Then pre-production to actually run the process the same way as mass production and validate that there's no very big issues, but usually there's always some issues that come up anyway. And then mass production with its typical challenges of being able to ramp up while improving quality, reducing the first pass yield, and so on, and keeping component manufacturing, assembly, and so on consistently good, right? So this is at a high level what we call the NPI process. Now, how does the NPI process actually reduce the risk? I think that's the most important thing to understand about the NPI process is that you start with an idea, and an idea is 100% of the risk, right? Risk is still 100%. Then you remove some of the risk by documenting the product requirements, okay, making them as specific as possible. And what you do is you actually give clarity to the product development team so that they don't go in their own different directions and so on. And just by asking yourself a lot of questions, you can already foresee some risks and avoid them. Okay. Then the phase that usually is by far the most important is what we call feasibility study. Again, it might imply proof of concept prototyping and testing. It might imply looking at some other products, how they were made, how they went around some key issues, what design decisions did they make, and so on. Industrial design, showing that in a sketch way or a very rough way to some users to see if actually it fixes the issues that the product is intended to address, etc. There's a lot of work here. The output is usually the design architecture. Then it goes into prototyping, and some of the engineering work has already been done, some of the sourcing has already been done, etc. Right? But there's always some issues to uncover, to address. There's always some unknowns here. Now, the more software is in the product, the higher this bar would be, right? Or at least if you keep it for prototyping, because a lot of companies do some of the sort of very special or at the high risk software development, let's say, in the feasibility study. But of course, that means feasibility studies can take several months, right? Okay. Then after that, again, if there is tooling, aesthetics, but also the products will then be made of parts that have the same physical properties as the mass-produced products. So that's typically the time to send for some reliability testing, compliance testing. Okay. Then pre-production. So basically, you run the same processes as mass production. There's always issues that come up, even if you've done a process FMEA and so on and so forth. There's always some issues. So you address them, you get to the point where it's ready for manufacturing, then you go into mass production and you have to ramp up, you have to keep things consistent. But really, as you can see, the amount of risk chipped away every time is not insignificant. It's very important to address this risk, right? But it's nowhere near these three first phases, where, as we say, this is more about discovery and this is more about delivery, right? It becomes much more predictable, more linear, whereas here there's a lot of trial and error, trying things. Okay, we went in the wrong direction, let's go somewhere else. It's more messy. Okay, I hope that was useful. Let me know if you have any questions. Thank you.